Good day to you all, students. How are we today? Hope we are all good. We'll be having our usual online class today and looking at a technical drawing on the topic conversion of orthographic view to isometric view. I come again, conversion of orthographic view to isometric view. What we simply mean by this is when you see an object drawn in orthography, then it means scattering or dismantling the assembling of the work. That is, what has been drawn in isometry was dismantled to be in orthography, either first angle or third angle projection. So before we talk deep or check what we have to do today or go in detail, we need to have our usual sharing of the objectives for this lesson. Talking about the learning objectives. That is, at the end of this lesson, you should be able to describe the parts of an orthographic view, then convert an orthographic view to an isometric view. This is what we need to look at. Then we go to the content or the details, that is identification of parts. Before you be able to, I call orthographic dismantling, then isometric is coupling of the parts. What was scattered or shared or separated will now be arranged and fixed together as one. That is the conversion we are talking about. Before that, we need to know what these parts are. If you do not know the parts that you want to assemble, you will not know where to put them. Else, you will take one and leave two and then pick three, as the case may be. So you need to identify these parts that you are trying to gather, to couple, or to fix together, or to make one. That is what we mean by the identification of parts. These parts, what are they? They are not like the parts of machine, where you talk about the gear, the wheel, the axle, and so many other. These are the three parts that make up the object that is drawn in orthography. Then you take 1, 2, 3, then you fix them together. We have in our last class discussed the front elevation shown in a particular arrow as being given. Then the plan, what you see when you look from above, that is vertically downward. We've also discussed the end elevation. That is what you see here and see here. In drawing orthographic projection, we discussed the first angle projection, and we also discussed the third angle projection. We said in first angle, recall or remember, we said in first angle projection, front view or front elevation is at the top while the plan stays below. The plan is drawn from the projection of lines from the front elevation. That's what we say. Then you now have a division at the next quadrant to your right or to your left. You take it up and then you produce the end view. So these parts still remain the plan, the front elevation, and the end elevation. The front elevation, as I've told you, is obtained by looking at the object in the direction of arrow A. This arrow in our last class, I also told you somebody can call it Y, but it has a particular thick arrow with a thick line that shows that this is where the front view is. It is being indicated. But in the case of orthographic projection, nobody will give you this arrow. You only will be told that this was drawn first angle or third angle projection, as the case may be. Then if you are told it is first angle projection, for example, you definitely will know that what is on the top is the front elevation. It is beneath it, they got the plan before the end elevation. You should know that the end elevation or end views are staying side both sides or one side of the front elevation. While the front elevation is on top, you should know that if you are told it is first angle projection. If it is third angle projection, definitely know that the plan is on top while the front view is below. And then the end elevation is drawn below too. That is at the side of the front elevation, because the front elevation in that case is down. That is what we mean by the differences between the first angle and the third angle projection. The same RB, looking in the direction of RB, shows you the plan too, that this is where the plan is. These are the parts you know. But like I've told you, the end elevation could be either this side or this side. Then in isometric, they are given or being identified with given arrows. Let's look at the orthographic of its own. Then what are the procedures you use? This one does not really require a particular procedure. Somebody may start to draw the plan before the end elevation, but I will give you a method that will be suitable for you and easy for you. That is, starting, for example, orthographic drawing is drawn in first angle projection. You are given that it is drawn in first angle projection. Like I said, definitely you know that the front elevation is the one at the top. Then you draw the front view using continuous line. Use a continuous line. That is, you draw the horizontal line, you project. We have discussed all this and we have treated them. You take the perpendicular line, the inclined lines are drawn at 30 degrees. Remember, receding angle of isometric, because you are not drawing isometric. You want to couple what has been dismantled. That is what we mean by this. Then you draw the plan of the orthograph view in isometric. That is, after producing the front elevation, you now know that there is a place the plan will stay. It could be step, like some people call it a staircase. It could be in form of the front elevation, could be in form of staircase after provided or produced. You now know that the plan will be on the top. Then it is your own responsibility or using your knowledge to know how you will fix the plan. Then also remember, you can project lines, hidden lines with to produce the end elevation or end view before you put the plan, depending on the method you want to use. Lines are projected from the front view down to determine the plan in orthographic. Don't forget this. So whenever you are drawing, remember in front elevation, lines came from the front elevation down to the plan. Therefore, the top dimension is also gotten from the front dimension, that is first angle. So the plan, that is the top we mean, that is the top of the view. Your plan that you now put will be determined by, you will look at the front view and then how they got the plan. So the size there will be what will be fixed on top, while you are now drawing the plan in the isometric now. Then determine and draw the end view from the plan. When you get the plan on the top, what is hidden there will be the end elevation. That is what we mean. They complete the drawing. Let us look at some steps. I have an example here. This is an object that is drawn in first angle orthographic projection. First angle orthographic projection. You know what is here? I think you answer this question now. What is here as I put this mark? Yes, this place I'm touching. The front view. All right. This is the front view. Because I said it is first angle projection, you don't need to consult any herbalist or oracle before you know that front elevation or front view is dropped here, because it is first angle projection. Then what is down here? The plan. The plan is drawn beneath. And what do you call this? The end view. This is angle what? This place here, before drawing this line. Angle 45 degrees. Thank you very much. So these are the parts you will identify. That's what we mean by identification of those parts there. You first of all identify them. By the time you identify them, now know, okay, this is what to do. In this example, for instance, I used this to start. I started with the front view. Now let us look at it. After drawing the front view, you could project this with hidden details. Then you put this one boldly and then complete this. Let us go to the next step. You see, this is just the front view. That is what you are saying here. That is here. Here is 10. Here is 50 mm, 20 mm, then 30 mm, away from 20, making the total of 50. That is the front view you have. This is the front view. A line, horizontal line is projected here. This is the horizontal line. In our usual manner, you take the perpendicular line. This is 10. Then here is 50. Here is 20 up. Then here is 20 with 30 degrees set square, as usual. Then you take the perpendicular line here. That one is 10. Then now complete it here, 20. So 10, 20, 10, 20. This is, sorry, 10, 20, 10, 30. That is 20 plus 30 gives you this 50. And here is 20. That is 10 plus 10. This is the end, the front view. This is the front view of the isometric object you want to produce. Having done this, we have drawn to the right. You need to also draw to the left. That will give us our end views, and then we now know how the plans are. But the end view in this case will be hidden until we now get the plan, we now complete the end view. That is the method I use. Just watch and see the next drawing. These are lines projected at the down here, you project a line, and at the top here, you project a line. At this down here, you project a line. At the top here, you project a line, and at the top here, you project a line. They are just going to the left-hand side. That is projection of lines with the 30 degrees set square, and at an angle of 30 degrees. Just be projecting them at top, the bottom, top, bottom, as the case may be. Just going there. Then you will now take a line from this button here. You measure a line to this side and take 30 millimeter, that is 3 centimeters. That is because this end view here is 30, 10, 30, 10. That is why you have that 30 there for the end view. That is what you are saying here. You will now take a line here to this side, that is 30 mm. Then from top here, 30 mm. From just like that, and you go. Let's see the next one now. That line is being taken. That is from here. You take a line, 30, measure 30 mm. You make it bold. Then from that end, you make a perpendicular line. That is 10. That is equal to this particular area. Also, make it bold. You could join here, but I did it. I want to project also. That is the next stage you see. Here, I want to project with the 30 degrees set square. I have projected like this, project like this, project like this, project like this, project like this. That is what you have said with the 30 degrees set square. So we have taken this as 30, here 10, then you project here. The same 20 that is here will be here. Then you project up, that is 10. The same 10 that is here will be here. The next thing is to project the last one. Anywhere it means this projection, that is this place. Stop, makes the end there. That is what you will see here. That is what you will see here. I have projected from here now. I've taken the line down. Then you see this line is coming from here, coming to this side with the 30 degrees set square. Then this one is coming to this side too with 30 degrees set square. You project this line. Two of them make here. You make here bold and then make here bold. That is the next thing we will look at now, making that side bold. You know what I mean by making a line bold. That is this place. Here has been made bold to this point, and here has been made bold to this point. This is how far. Now, from this, what you are saying here, you now have a plan, that is the top here, and another plan, top here. Remember, we've only drawn the front elevation. We now can now see a plan here and a plan here. Two. Then a hidden end elevation that has not been made bold. An end elevation here and another end. like I was saying, we are sorry for the transmission, breaking transmission. I was telling you that from what you can see now here, that this particular point is the last projection we did here, and then we did another projection here, both of them meeting at this particular point. When they met there, you stop, then you make here bold, you make here bold. That's what is to be done next. Then you now see a plan here, a plan here. You can identify the plans or the plan now. One at the top there, then you step down. That's why I said some people call it staircase in this particular type of object. Then you could see a particular rectangle here. This side is the end elevation, the end elevation here. The two are already being shown there. But you have not been able to, or you have not made them bold. The next thing for you to do is to use your ruler to join here to here with a bold line or thick line. Then this down, you join it with a bold line or thick line. This top, you join it with a bold line or thick line. You have produced that object. This is the object that was scattered. Let us look at it here. That is the last stage. Isometric block produced or drawn. This is the last stage. Here to here has been made bold. Here to here has been made bold. Here to here has been made bold. So you can now see a clear plan. That is from here to here, 30, 30, 30, 30. That's a square plan. Then another one here, 30, 20, 30, 20, a rectangular plan. The two of them are shown there. Then the end elevation is 10, 30, 10, 31. Another one, 10, 30, 10, 30. 2. These ones are seen here. These are what you are saying. 30, 10, 30, 10. The second one, 30, 10, 10, 30. You do not need to ask questions on this because we have treated how to draw a plan and they review all of them in orthographic. This is coupling of what were dismantled here or what were scattered in this particular place is what is in. So if you are given an isometric block like this to draw in orthographic view, you will do it to be in this way. That's what we have treated before. But this time, you have been given it in orthographic like this, showing the front elevation, the plan, and the end view. So you are now asked to couple it to make it an isometric block. That is how it goes. You have produced the isometric block. But I will not forget to tell you, like I said, there are many methods you can use. Somebody can start from, or may start from the end view to project down and take it up. You can do as many practice you wish to do. Remember, I have told you, the paths must be identified. That is the plan, knowing where the plan is, the front elevation, and then the end elevation. If you do not know all these things, you will be drawing the wrong one instead of the right one. There are steps too, but these steps I've told you, they vary depending on how you want to start it. Also, do not forget, while watching my video on technical drawing, remember to have your instruments with you. Whatever stage, like we have seen here, whatever stage we are, like we've seen on the screen, in stage 1, after drawing the front elevation or the front view, after drawing this, after watching here, you put your instrument, do it. If you're having a problem with the dimension, you go here. That is why I put the dimensions here on the orthographic. Ordinarily, you're not supposed to have it there, just for you to have a guide, because it is you that will put the dimensions now on the isometric block. It is always saying that. So when you are being given these dimensions here, then you know what to do. You have seen 10, you have seen 20. That means here, away from here, we give you this remaining one, 10. So there are ways these things are being dimensioned. You see the dimension, then you do this, you lay your hands on them, and then you try to do this one. When you have finished this, you now know, okay, I can now go to the left or go to the right. You also watch my next step. That the next step I did was to go here, and then you project your lines. You pause your video. You go to the next one also. You check, okay, I've now started moving back to the right. After moving to the left, it is now like this, like this, like this, like this. Then you are moving to the right to complete the other ones. Then you see what was done here. You do your own too. Then you go to the next stage. You see how I made that place bold. Remaining just the last plan, that is the top plan there. Then you can see how I got the top plan. Then remaining to fix the end views or the end elevation. It was gotten here. So do not forget to follow these steps, be with your instruments, and do the right thing. Don't say, I've finished watching, I know everything. One day you just bring your instruments, you may not have problems. Better you follow the step and then you do it gradually. Then you get it. You'll be happy when you do, as we normally do when we are doing it. In the studio, in school, we're always happy when you get the object being produced. You begin to smile. You'll be happy too. Thank you very much. God bless you. Stay safe wherever.